We thank you for joining us, and we'll wait for a couple of minutes before we start the session so that we hopefully can wait for a few others to join our session. So we'll exactly start by 11 or just a 1 minute just to give this time space for the people who are joining. Thank you. Good morning, everyone. So a warm welcome to all the audience who have joined us today. Uh, it is said that 2 minutes of energy resource 2 minutes of energy resource, or the every 2 minutes the energy resource that we receive from the sun to the earth is almost equivalent to the uh, energy consumption of an entire uh, annual maintenance of an entire human life. That is almost like the all the air conditions that we run, or all the cars that we drive, the energy consumption done by with the cars, vehicles, air conditions, TV, remotes. So name it, all the energy consumption is just 2 minutes of sun rays. So that's exactly one of the reasons what's the potent of the energy rays that we get from the sun. So exactly today we are going to talk about a energy resource that will renewable energy resource that converts those energy into a viable sustainable energy resource to all our human consumption. So welcome all to the power your SolidWorks design with SolidWorks Solutions, solar designs with your SolidWorks Solutions. We have today's presenter is myself, Madhusudan, and we have Shishel, who's going to demonstrate on the uh, uh, analysis part, and will tell you that how exactly the SolidWorks will work. And then you have Sindhu, who's going to work on the electrical part. She's going to showcase and demonstrate on the things on the electrical front and how exactly SolidWorks Electrical will help you out. So let's start. When I talk about the basic SolidWorks, uh, so when I talk about the solar industries in particular, what is the entire the what is the total contribution of the non-renewable resources? Solar plays a major role in contributing to the solar energy is one of the non-renewable resources that helps you in the major contribution. There are places like Denmark which almost contribute 40% of their total energy consumption. So India and most of the other countries are catching up with that, and more than that, it is an industry that is pretty much on the rise, because that is going to be the way future. So what are the challenges that we do face? What is stopping us from getting that to the 40%? As we all know, most of the solar energy cost and power tariff is one of the major source, and we need to check how exactly we can reduce the cost and project deadlines. As we all know that anything that uh, uh, shoots up beyond the deadline times will always reduce the cost or the profitability to the manufacturers. So that is one of the most important thing, and anticipate the external factors like wind, snow, and temperature. Of course, this is we are talking with nature. Nature is the most unstable thing presently in the current scenario. Nobody can predict nature, and that is since solar energy is totally dependent on one such scenarios where it totally depends on the energy source coming from the nature, so it is unpredictable. And what are the other impacts? Like, for example, the high nature environment dependency, the power output is dependent on the nature, as we all know. The solar radiation, it depends on the place that where we are as well. For example, there are places like Iceland and all, where solar power may not be a viable option. And there are places like uh, Rajasthan, where is the primary source for solar energy, but yet because of the non-availability of water with the maintenance, annual maintenance, it is not even that easy to extract solar power energy. So multiple topographies have different challenges when you talk about solar power energy. So how does SolidWorks help you to achieve this? So let's dive in deep and check how exactly we are going to do that. We have a design that will help you do it, and also we will have a design validation which will help you to determine what is the amount of load that is falling on your solar structures. And of course, when you talk about the solar, there is no place if there is no electrical connections to that. We cannot extract without the electrical connections. So we're going to see that how ECAD and MCAD integration, how SolidWorks will help you to achieve that, and control quality control, and also That is going to be one of the major things. And then you have the technical documentation and collaboration that I'm going to talk about. So let's talk about the first thing. So any design, any solar project will start with the basic concept. That is your concept. And with every concept, you need to have a blueprint of a design. So how does SolidWorks contribute to this? So with your SolidWorks 3D CAD tool, we have certain number of tools inside SolidWorks which acts as one of the most major contributors in bringing your dream of the solar power to the reality. So let's see in deep that what is this SolidWorks CAD tool offers to the solar designs, and how exactly you can benefit from using these tools. So when I talk about the first thing is first, so that is the structure assemblies. Configuration will play a major role. As we all know that tilting of the panels are very much important in the solar designs. That is the most important thing that we need to understand in terms of how the solar panels tilt according to the sun rays, tilting of the sun rays. So how does SolidWorks help you to do that? With the help of SolidWorks flexible designs that we have and the robust designs that we have, we will be able to create multiple configurations in a single model. You don't have to create multiple variants for that, and at the same time, you can also create the animations where the tilting effects can be showcased over there, and even the designs can be pretty much robust comparing to all the other designs that you compared to all our peers. And it's pretty easy to use, and some of our clients are started using this for their basic design. This is one of the major advantages of using SolidWorks. With the help of configurations, they can manage their designs in a easier and a lighter way. And the next is inbuilt and structured designs. So how do we do with the structured designs? So when I talk about solar industry, the first thing that comes into mind is fabrication. So how does fabrication really work? With the help of SolidWorks Weldments, SolidWorks helps you to easily achieve this fabrication with the help of Weldments. The inbuilt libraries that we have, in the inbuilt libraries, not only you get the basic standard C channels or circular tubes, even your T sections or your the profile alignment, those things can be completely aligned. And with the weldment profiles, it doesn't really stop you from the basic industry standard weldment channels. Even the customized weldments, just in case if a company is going for customized weldments because of the requirement of their company, they can also design their weldment structures or the profiles according to their need, and you can align them according to your source, how you want them to be aligned with based on your designs. So as you can see, I'm just selecting from the a single sketch. I'm just taking multiple weldment profiles in a single sketch, and SolidWorks is so flexible that it allows you to easily manipulate your designs in such a way that your designs doesn't take much time in creating those fabrication units, and yet you can also create your custom weldments and customize it inside your weldment profile, making sure that you can extract the cut list, which will be helpful for you to taking that fabrication, helping your fabricators to do an easier job. So next thing, what does the smart fasteners do? So how about putting all your structure designs together? What do we need? As we all know that fasteners is the thing that will help you to put all our structure designs together. And how does SolidWorks help you to create some of the fasteners? But when you talk about fasteners in a solar design, each solar structure will consist of more than 5 or 6 bolts in a single piece, or in a single particular bolts that we have, or in a structure, or in one particular weldment, we would have more than 5 or 6 fasteners coming up. But how do we reduce the time in adding up the fasteners, making it more of an automated process? With the help of smart fasteners or the toolbox, take the full advantage of SolidWorks. We can designers can take the full advantage of SolidWorks toolbox, where they can select the particular feature or the whole pattern that they have inserted in that particular assemblies, and SolidWorks will decide, or it will only select the fasteners that you want. It will do a smart fasteners. That's the reason we call it as a smart fasteners. In just in case you want to change the fasteners, default fasteners that you want to, that can also be possible with the help of XR bolt, or if you want to change any other standards. And one more best thing about SolidWorks toolbox is that you have all the standards, industry standards that most of the companies follow. It could be ANSI or fancy designs or DIL standards that followed in Russia or ISO standards, you name it, you have all the standards. But that doesn't stop you there. Once you add up all the screws over here, you can also add the bearings to it, and also you can add the nuts to it. SolidWorks toolbox is designed in such a way that all the other parts, once you add a particular screw there, what all the other requirements, SolidWorks itself will help you to tell you that, and will give you the entire set and the feedback then and there. So this will reduce your time to a major level. At the same time, it will also reduce in searching the component. For example, it so happens that some of the customers would be using so and so bolt, but they may not be finding it, the CAD model, inside the any internet forum or any other forum. At that point of time, a toolbox will be a very handy tool for most of our designers. But now we are done with the toolbox. What about the smart components? So if I have created some of the panels, what about some of the features that we do? We do know that solar is a standard components. We will have some standard designs. Is there any way where I can also standardize the features and make some of the components more of a smart components? Yes, with the help of smart component libraries or the smart component features inside SolidWorks, you can take some of the components which carry some of the features along with that. You can make them as a smart component. Just in the case of what we have done over here, when I click on one particular component, it will just ask me for the reference. When I'm inserting a smart component, it will just ask me for the reference. What is the reference that you want? You can easily define it, and with the help of the selection manager that we have in SolidWorks, you can easily select the faces where you want to, even at which are not seen in your graphic area. With the help of selection manager, you can easily do those, select those areas as well. So with that, I can easily add the smart features over here. When I add the smart features, or the smart components, it doesn't just add the smart component over there, even some of the additional features. For example, the cutout holes for this particular fasteners, when I'm adding this holes, fasteners directly to this particular structure assemblies, let me just isolate this component and showcase you that the features which has propagated along with the part that I've added there, smart components that I've added there. So this is the power of a smart component, which will reduce your time and also make your work much more easy and simple. So let's talk about the detailing mode. So this is something that has been newly introduced in SolidWorks 2 years back. Some of them would be using this, but when you talk about solar power designs, you are talking about a large assembly drawings. A lot of assembly drawings sometimes takes a lot of time because of loading the entire assembly files, and you are talking with almost 1,000 files or 1,000 components in a drawing files. So how do we manage them when I even want to do a small detailing part of it? When I've already inserted those views, how do I make some small changes? Or if I really am doing the detailing part, I don't need the entire model to be loaded on the file. At that point of time, you can use this detailing mode concept, where you can select a particular drawing and open in a detail mode. When I'm opening in a detail mode, you can add the annotations and the basic changes that you want to make, and you can also add all the sheets. Along with all the sheets, SolidWorks drawings will be loaded with minimum graphic requirements. So this doesn't mean that you cannot do just for the viewing purpose. You can also add some of the annotations here. Even balloonings can be done. Even your revisions, for example, it could be just an ECN changes that you want to make with your drawings. At that point of time, this would be a very useful resource for you, or the option for you, where you can select the revision clouds and all that, make some changes that you require for the ECN changes. And that doesn't stop you there. Even you can save it as a PDF document. Once you save it as a PDF document, you can review the designs, and it will save the entire file as a PDF document, and you can start opening that and review the designs. So this is the advantage of the detailing mode that we have inside the SolidWorks drawings, which has been newly introduced from 2020 onwards. So one of the, I think you can start using this option as well. This is a very useful option. Most of the companies which deal with large assemblies are using this, who are in the detailing of the large assembly drawings. This would be a very useful tool for them as well. Now let's talk about a concept that comes in little bit new to some of them, that is paperless manufacturing. What about taking off the drawings as well? Is there a methodology where I can use my 3D model and I can give all my annotations in my 3D model at an instant time? Yes, I can do with the help of the drawings or the MBD that we have in SolidWorks, which runs along with my CAD tool. You can define the PMI data, that is a product manufacturing index, organize the data how you want it in just like how you do it in a regular annotation or in a drawing file. In the same way, we can organize it in your company formats and give the outputs in a format that would be usable by most of them downstream application, whether it could be a step file or a 3D PDF. So you are generating a PDF with the SolidWorks, but a 3D PDF with the SolidWorks. But what is so different with the embedded PDF? So the PDF that we generate in the MBD, we'll just see that. And also the best part here is you can, every sheet of SolidWorks has something like the basic variants of the MBD dimensions, where you can add the dimensions to the 3D model. But along with that, the MBD, the regular MBD, it offers you something more than what the MBD dimensions offers. That is, you can extract the particular model or the views which we have captured over here, and we can capture each of the views that we captured the same way we captured in our drawings. Same way we can capture that. Along with that, we can also, each of the captured views can be exported to a 3D PDF, and these PDF can be opened in a format where you can put it in the same format what you follow in your basic detailed drawing. That is, your drawings, you put your company logos and all that, right? The detailed company formats. In the same way, we can do this with the help of this 3D PDF that we generate in the MBD. We can replicate the same thing that what we do it in the drawings, but the advantage over here is we can view the files in a 3D. But although the files might be in a PDF document, but we can view the files in the same way that what we in a more an organized and a structured format. So this is about the basic designs that I was talking about, and some of the small features that I thought would be very useful for the solar manufacturers. So now I'll pass on the baton to Srishel. Srishel will take you through the design validation and how exactly design validation will help you to do that. So over to you, Srishel.
Hello. Thank you, Madhu. Am I audible now?
Yes, you are audible.
Thank you. 1 second. Let me put it on presentation mode. Yeah. I hope my screen is visible, right?
Srishel, your screen is visible. Yes, your screen is visible.
Yeah.
You can go ahead.
Yeah. Good morning, everyone. Once again, I would like to thank you for taking your time and attending this particular webinar. And where Madhu has already given a brief overview on the various capabilities in terms of design, in terms of a model-based definition, in terms of 2D manufacturing, drawing creation, and model-based definitions. Moving further, I'll be taking you through the various functionalities within SolidWorks in terms of validating your solar structure design, because it is always very much important for any solar structural designer to understand the effects of wind, and thereby understanding the strength of our structures that we design for our solar structure. And finally, it is also very much important to understand the strength of the bolts and how much load is coming on each of the bolts to basically decide on the foundation bolts to overcome the effects of this wind load. Okay. Coming to the standard, especially most of the design process for solar industries are followed by making use of a standard design code called IS 875 part 3. And IS 875 part 3 is basically a code of practice for design of loads for most of the building and structures. And here is the small map which gives an idea of wind speed across India, in a different region of India, where let's say, for example, some of the regions are having a wind speed of 33 meter per second. Some of the regions of the country is having a 47 a meter per second of velocity, and similarly they will be varying. Here I will be taking you through the different speed of wind load, and we will calculate the strength of our structure based upon the different wind speed. And most of the industries, today they are calculating the strength of their solar structure design without considering the fluid structure interaction, where SolidWorks simulation and flow simulation provide you the platform wherein you can import the load from SolidWorks flow simulation by making use of a fluid structure interaction, and then you can calculate the strength of your structure with respect to wind loads. Okay. And for this particular solar structure, as already Madhu has shown in his slides about the design of this particular solar structure, where we have considered 32 number of solar panels, and we will be calculating the strength of our design by making use of IS 875 part 3, where this particular IS 875 standard code considers the various effects like factor of basic wind speed, and what is the coefficient of risk factor. So many things they will consider into account, and then they will do the hand calculation. That is a little bit time taking to do the calculation, especially where structures complexity increases. This is where SolidWorks flow simulation or virtual testing capabilities comes into picture and comes into very handy in terms of getting the result at very faster rate and in a very earlier stage of a new product development. Okay. Here I have the solar structure, which Madhu has already explained. If you just see this particular graphic user interface, it is just SolidWorks graphic user interface and SolidWorks simulation and SolidWorks simulation. That is a CFD simulation and finite element analysis solutions are just add-on to your existing CAD system. That means to say there is no absolute need for you to switch between the windows for doing 3D modeling and for doing the your simulations. Here I have created a flow simulation study for a particular wind speed, where it basically walks you through the selection of type of units, type of study, and what type of fluid. Especially for this aerodynamic application, it is my fluid is going to be air, and the initial condition where I'm designing it this particular structure. I want to understand the wind loads with wind speed of 42.3 meter per second in jet direction for this case. And by just giving those parameters, then the main objective of this study is to understand the uplift force, especially at this particular location. So uplift force is always very much important to understand the strength of our design, or in order to design your structures, in order to design your foundation bolts and many other aspects. So here by making use of various goals, you can calculate the uplift wind force on each of these surfaces, and you can calculate the normal force and also the total pressure. How much pressure is being distributed on this particular surface with given wind speed can be estimated by making use of various goals. Okay. Here again, coming to the meshing, the finite volume mesh is being automatically created. There is no need for you to do a manual meshing, and we have excellent post-processing functionalities in terms of calculating the various parameters related to fluid dynamics and thermodynamics. Here I have plotted the velocity distribution. You can just see how the velocity is varying when the wind is blowing from this direction in a positive jet direction. Not only velocity but also other parameters, as I said, the pressure. Whenever you are doing the thermal analysis, especially when you are doing the thermal solar radiation and all, the temperature distribution is always very much important. If you name any parameters related to fluid dynamics or heat transfer problems, we have the post processing functionalities to calculate them, including your kinetic energy and turbulence intensity, noise parameters, and many other aspects. And as I was talking about, the pressure distribution at this surface is always very important. So by making use of a surface plot, you will be able to calculate how much pressure is being distributed, where is the maximum pressure, where is the minimum pressure. Everything can be visualized by making use of this surface plots. And finally, we can export all the goals to Microsoft Excel, or you can see the results here, like what is the maximum uplift force at this beneath the structure. How much it is coming can be estimated here. In this case, it is coming 97 kilonewton for a given wind speed. Now the next question comes to our mind is, what if my wind speed is different? What if my solar structure is situated in a different region of the country where I'm having the different wind speed? For that, we have something called as a what if analysis. wherein you can just input different velocity. For initially it was 42.3, and then it is done for two different iterations. For doing these two iterations, there is no need for you to start the analysis from the scratch. You can just make use of this parametric study, wherein you can just link the velocity of wind, and then you will be able to calculate what is the uplift force with the change in the velocity can be estimated by making use of this what if scenario. This is how SolidWorks flow simulation helps you in terms of understanding the wind effects, understanding the velocity distribution, and understanding the pressure distribution, and many other aspects with regards to fluid dynamics and thermodynamics can be estimated. And here is the surface plot where you can understand where is the maximum pressure. And also we have seen like with a given wind speed, what is the total uplift force is coming like 97 kilonewton, and as I said, I'm using a 32 panels. If I divide it by 32 panels, I'll be able to calculate what is the total uplift coming per solar panel can be estimated by making use of this particular calculations. The reason why I have calculated per panel is because I have done one comparison study done by making use of a hand calculation, and also I have compared the results of SolidWorks flow simulation, and then we have measured the accuracy of our software. For a given wind speed for like 47, 33, and 55, according to this particular standard I was talking about, by means of hand calculations, we got the uplift force per panel is this much, and we are getting the results of almost similar. We are getting an result variation of from 3 to 6%, which is more than acceptable in virtual prototype testing like this software. Okay, and after that we can do a lot of what if scenarios, like if you have the whole solar farm to be calculated by making use of SolidWorks flow simulation, it is very much possible, wherein you can just pattern the structure to populate the entire form, and then you can apply the same boundary conditions, and you will be able to calculate like what is the velocity plot, pressure plots, and many other aspects related to fluid dynamics. And not only the different types of solar panels, but also if the wind is blowing at a different angle, here it is blowing at a 45-degree angle, those things can also be parameterized. Design of experiments or what if scenario helps you to calculate various parameters by making use of SolidWorks flow simulations. Here are the results with a 45-degree angle with which wind is blowing, and again the pressure plots, and similarly you can calculate all the things related to wind effects. This is how the CFD analysis inside SolidWorks flow simulation is useful in terms of understanding various parameters affecting the performance of our structures with respect to wind force, snow, or temperature. And moving further, only the CFD analysis will tell uplift force, but we also have to understand what is the impact of this uplift force on our structure. Like what is the factor of safety of our design, how much stress is being developed, how much deformations is being developed. Everything can be of very much important for us to in order to overcome the failure of our structures with respect to this wind speed, right? So for that we have a finite element analysis solutions, wherein you can just import the loads from SolidWorks flow simulation to our structural solver. Our structural solver is basically a finite element analysis solution, where it basically, again, I'm not switching between the windows. I'm in the same window where I will create a new SolidWorks simulation study, and then I will just apply material properties like what material this structure is made up of. Then I will, import the load. There is an option where I can import the loads from CFD analysis. If you just see, I have imported the file from CFD analysis, that is .fld file from flow simulation, where it basically takes the wind load effects to your structural analysis. Again, the finite element analysis makes use of automatic mesh creation, and after that you will be able to calculate what is the maximum deformation that is being developed due to this wind speed of 47.3 meter per second. You can observe what is the maximum deformation, and in a similar manner you will be able to calculate like displacement. You can just see the animations, how with respect to the wind velocity, how they are being deflected with a deformation scale of 1 I have put here. And then you can understand the axial stresses, bending stresses, axial force, bending force, moments, torque, and everything can be estimated with the help of finite element analysis post-processing functionalities. And finally, I was talking about the reaction force at the foundation. The reaction force at the foundation are always very much important to decide on the what type of bolts should we use, what type of connectors should we use at the foundation to overcome the failure of these solar structures. And especially when it is this structure is made up of a lot of columns and vertical columns and horizontal columns. For this, it is very much important for us to understand buckling analysis also. Whereas we have the buckling analysis wherein you can calculate the buckling factor of safety. Let's say, for example, buckling is factor of safety is less than 1, and if it is falling between 0 to 1, you can estimate based on these values whether it is safe to buckling, or if it is failing due to buckling, or if it is collapsing. Those things, different parameters can be estimated by making use of a buckling analysis. Along with buckling analysis, we also have a various vibrations, natural frequency response spectrum, earthquake simulation. Everything can be done by making use of our finite element analysis solver. And moving forward, I was talking about the bolt strength, especially at the foundations. Let's say, for example, from the CFD analysis, we have understood that there is a total of 97 kilonewton load is coming on each of these columns and pulrins. There are 8 columns, 6 numbers of columns are there, and a number of pulrins, that is horizontal columns are of 4 number. And if you calculate the force per column and force per pulrin, it will come around like this. And if you apply same force on these particular beams, you can do trial and error, or you can optimize on the bolt, that is the size of the bolt, whether we have to use M10 and M16 bolts, or we can replace that with a M10 to M12. And how do we optimize on the size of the bolt can also be estimated by making use of finite element analysis solver. Here is a quick snapshot where I have compared the results of bolt strength. Whereas the M10 and M16 bolts with alloy steel, if you observe this color code, the green is nothing but these particular bolts are safe, and the red is nothing but they are failing. Some of the bolts are failing with respect to this wind load. And if I replace these bolts with M12 and M16, my failure is reduced. Still, there is a scope for me to improve my design with respect to the given wind speed. This is how finite element analysis helps you in terms of validating your design in a very earlier stage of a design to avoid the possible failure in the practical conditions. As I was talking about, the benefits of these connectors helps us to understand efficiency of the bolts and weld calculations, and they help us to investigate the what type of connector should be used for our design, so that our bolt and weld will not fail in practical conditions. And in a nutshell, this SolidWorks simulation solutions, both finite element analysis and CFD solutions, is built-in intelligence simulation studies. They are very much integrated, tightly integrated within a SolidWorks, and to validate your design at a very faster rate. This is what I had to show you in terms of a design validation. If you would like to know more or in detail about SolidWorks simulation for your application, please do please do type your request in our chat box or question window, so that we will come back to you, and we are more than happy to present our solutions, especially with the simulation and other capabilities. With that, I would hand over this session to Sindhu. She will be taking you through the integration of mechanical CAD and electrical design. I'm just making her presenter now. Over to you, Sindhu.
Yeah, thank you, Srishai. I think my screen is visible and my voice is here.
Yes, your screen is visible and you are audible.
Yeah.
Thank you.
So yeah, thank you. So from past 30 minutes, we just saw how we can go about the SolidWorks design with SolidWorks, and then also we saw how the design validation helps us in getting our design better. So now after the complete designing and the design validation, now let's say if I have to go about with the electrical designs, how I can go about. So let's see how the SolidWorks electrical and mechanical can integrate together and get the best solutions with SolidWorks interface. So first, as we all know, when it comes to any of the industries, there will be certain design challenges which the designer has to look for and then follow all his agenda with respect to the project. So here, let's also see what are all the electrical challenges when it comes to the solar panel industry or any designing industry it matters. So first and foremost thing what any designer would look for is to check whether the components which is required to design the solar panel, let's say it could be a connector or it could be any of the components like let's say the combiner box or the fuses which is required for the complete designing of solar panel. All this has to be available in the design library so that they can make use of the those components and create the design as early as possible rather than creating it from the scratch. So in any of the industry, the library plays a very important role. Similarly, after the library components are being added, then we have to just go about with the wiring of those components to understand how the connections between any of the components are brought about. So after the wiring is done, it is very important to know that what are all the wiring numbers, which are the wires which is connecting between any two of the connectors, what are all its terminals, all this has to be understood. So for that, when it comes to any 3D routing, the wiring number plays a very important role. So that also comes into a picture where the designer can go with the manual process or automated process. And then comes the ECAD and MCOD collaboration. Since we have to follow the routing for the design what we have got from the mechanical designer, there has to be a single interface or an interface which helps both electrical and mechanical designer to work in one single ecosystem so that there is no mismatch in any of the values or there's no need of importing or exporting the file formats in neutral formats, which leads to some of the data errors. So all this has to be reduced. So we also have to consider this point as one of the challenges. And then comes the cable or wire length. That is, after the collaboration, after the routing is being carried out, the next thing is the designer has to understand what exactly is the wire or cable length to avoid the wastage of cost for the, which comes with respect to the overall project, where the designer might invest most of his cost in purchasing the wrong numbers with respect to the bill of materials, or it could be the wires or cables. The extra cost which is spent on all this can be reduced by getting the appropriate values from the software. It could be a bill of material or it could be a cable or wire length, so that the overall cost also reduces and the amount of time spent in doing the designs, everything can be reduced. And then, as I told, we must also look for the bill of materials, where the manual process leads to a lot of errors, like the designer might miss any of the components in his bill of materials, or he can add few more components which is not necessary. So all these errors have to be taken care before starting any of the projects. So now, after knowing the challenges, after getting to know what are all its challenges, we also have to make sure we are not making such mistakes in our project. So for that, there will be what the designers will do is he'll list out all his points where he has to overcome those challenges. So here, let's see what are some of the solutions for these challenges, what SolidWorks Electrical offers. So when it comes to designing of a solar panel, as we all know, first thing what any designer will start with is the schematic. Once the schematic is done, the next thing is to go about with the collaboration, that is the routing in SolidWorks with the help of SolidWorks. And then after generating all the routing, everything, we have to just go about with the reports, that is the output formats, whatever is required, like the wire labeling or the cable tags, or it could be the bill of materials. So all this has to be generated. So Here, when it comes to SolidWorks Electrical, we have an interface to create the single line designs. So we have from the library, since the component is available within the library, we can just get them onto the schematics and start placing them onto our interface and get the designs done in very less amount of time. And then comes the power wiring, that is the detailed schematic designs what any electrical designers will look for. And also we have to make sure the tool also has electrical design integration, that is the CAD and the mechanical integration within one single ecosystem is appreciated. And then comes the wiring harness. So since we are carrying out the routing with respect to the solar panel, we also make sure that the wiring harness can be carried out. And after the wiring harness is being carried out, the next thing is to generate the form board drawings or the flattened route for the same. So the tool must also help us in generating the flattened drawings. So SolidWorks Electrical provides the interface to generate the flattened drawings and create a harness from that. And then last thing is to generate the reports. We have reports or the options to automatically generate the reports from the components which is being added onto the schematics. So now let's look at the SolidWorks electrical product demonstrations. So before starting, let me just introduce you the interface. So the interface which is seen on my screen is the SolidWorks electrical schematic interface, where we can create complete schematics. So, and this is the SolidWorks interface which I have, where I have got the complete panel designing, and some of the panels which is available on my screen are completely designed by my mechanical designer within SolidWorks. So now the main agenda for me is to generate the cable or the wire harness for the solar panels which is available here, and then extract the cable length on the bill of materials from this. So if I have to proceed with this 3D routing, first thing what I have to look after is the schematics. So here, as I told, this is the interface of SolidWorks Electrical. Here we can carry out all our designs. So we have a project manager where based on the standards, I can just go to select the standards in which I would like to work with. There is ANSI, GB Chinese, IEC and Japanese standards. There are based on the electrical designers requirement, they can just go about with the different types of standards. So once any designer creates a project, there will be a project document which will be listed in this option called document. So under this, we have a document book which consists of multiple sheets like single line designs or the schematic design. So here, if I just go about, we have a cover page where the designer can just list what is all about, like the project introduction, who has done, what is the revision, description, who is the client, all the details can be entered within the title block. The title blocks are already available in the library. The designer can make use of it. And then comes the drawing list. So this drawing list, we also call it as an index sheet. So here the manual process can be reduced over here, where the designer can just generate automatically the drawing list. And then comes the system architecture. So here, if I just go about here, we also call it as a single line as well. So the designer can just go through the options. So here we can see the command. So if we have to insert any components, we have different types of classification, that is the library classifications which is available within SolidWorks Electrical. So we can see multiple classifications what any electrical designers would make use of it. So the designer can go to the particular classification, or he can go to the filters and filter the components as per his requirement based on the number of circuits and terminals, and get the required component and place it on to his schematics as quick as possible. So let's just look through the architecture. So here in this architecture, if we just see here, there is a solar panel incoming supplier, which is then connected to a combiner box, where the combiner box has got some of the fuses within it and isolator switch. After that is the power transformer, where which converts the DC supply to AC supply, and then the AC supply is then transferred to step up the power switchgear, and then it finally goes to a grid feeder. So once the architecture is being done, the next thing is to go about with the detailed designing, like how exactly are the panels which are being connected, and then from the panel where are all the powers is being supplied to, all this can be seen. So if we just see here, it's not just a dump symbol, it has got all the properties like what is the component all about, which is the location, what exactly its functions, and also we can see the manufacturer part. So here we have a manufacturer part which is being assigned, so the same manufacturer part will be updated in the report, so the designer can get the exact manufacturer part details and also the count which is being added to this project. So like this, individually all the details of the each and every component is being captured by the tool, and also we can see the wiring details. So here if I just go about with this detailed cabling, I can just understand what is the type of cable which is being associated, which are all the origin component, what is the destination component, how I have to connect this, all the cabling order can be set over here. And it has, this is not just a dumb line of which does not contain any informations or nothing as such. This is a intelligent wire or a cable which has got the properties what any cable or wire has. So we can see what is the cable numbering, all the details on it. And then here we can see what exactly is the power wiring. So here we can see fuses which are being placed. We can see the type of or the manufacturer part which is assigned to each of the fuse. So if I just go to the manufacturer part properties, I can see what are all the details which are associated to it, what are all the 3D part which is assigned, everything can be seen here. So once the schematic design, everything is complete by placing the symbols. As I told, there is a different symbol association for line diagram and also the schematic design. So in the schematic design, we can see the detailed schematic symbols what any designer would look for, just like for the single line designs. Even here there are multiple classifications through which the designer can select the appropriate symbol and place it onto his schematic and complete the design. So once the schematic is done, the next thing is to link the schematic with the 3D assembly, whatever is available here. So I have got the solar panel. I have some of the connectors which is being placed here. So through this connectors, the wire has to be routed, and then the cable has to be connected to this combiner box, and then it has to go to the high tension switchgear box which is available there. So for this to work properly, what I have to do is I have to just link whatever the fuses which I have placed here must be assigned or associated to the 3D assembly over there. For that to work properly, here we have the SolidWorks assembly, where through the SolidWorks electrical interface itself, we can just assign the assembly. When I double click, it will take me to the SolidWorks interface only if I have signed into my add-in. So here I have a SolidWorks electrical add-in which is enabled. So how this integration is brought about is once add-in is being checked in over here, there will be a separate electrical project document panel which will be available towards the right. So here what exactly we were stressing on the integration with our presentation today is this particular interface which is available on the mechanical interface as well. That is, the designer or that is the mechanical designer will be aware of whatever the changes the electrical designer will be doing in his interface. Whatever the changes he makes, the mechanical designer need not go in person and talk to the electrical designer. He can just open the project documents which is available towards the right side of the SolidWorks mechanical interface and understand what are all the changes or what are all the designs which is being made by the electrical designer. So this keep the two different interface intact. Also see whatever the components which were added in the SolidWorks electrical schematic panel. Here we can see all the components which are added onto the schematics. Everything will be available on the mechanical interface as well. So it's just that the designer has to right click and just associate all these components. Like if he wants to associate by defining J1, J2, all this, he has to just right click and click on associate, so that there will be a linking which will be assigned from the schematic onto the 3D interface. So after assigning all the components and linking it with each other, the next thing is to proceed with the routing. So here we have SolidWorks harness, SolidWorks routing harness, route wires, and route cables. So based on the designer requirement, we can just set, let's say this is the harness which I want to add up. So I can just make use of the spline or line options, and then I can just select all the harness and set all the parameters which I would look for. And once it's done, if I just click on that, once the process is run, automatically based on the schematic information, that is, it could be the wire or the cable, whatever is defined with respect to the dimensions, the routing will be carried out. So here we can see the routing based on the path which will be defined. So if the designer requirements is to pass a particular wire or cable in specific direction, you can just make use of this option called create route path. So by defining the path, the route wire or the cable will take the same path, and it will automatically route in the same fashion and give us the routing. So once the routing is done, we will get the updated cable length as per the path which is being created, so that everything, all those details can be captured from the schematic, where we have design rule checks. So if the designer wants to check if he has made any mistakes in the schematic, he can just go about with the design rule check, where there are configurators which is already available. So the designer can check whether there is any manufacturer parts which is not added, or any dangling or disconnected wires which are present in the schematic, or any of the empty terminal strip, or any details as such. If it is missing, you can just check in and just cross check whether there is any errors or not. Once the complete design, everything is complete, we can just go about with the routing manager, where even here there is a configurator for generating the bill of materials, or it could be any reports. So all type of reports are available within the SolidWorks electrical, what electrical designers would prefer to. So we can just check in all those types. We can see what are all the different types of wire style. We can see the updated length once the routing is complete. We can see what is the origin wire, what is the destination wire, the wire numbers. So as I told, here there is a formula based wires which is being added, which has got intelligent properties. So based on that, the designer need not enter any wire number manually. Automatically it will calculate based on the formulas which is associated to it. So based on that, it will just generate the wire number and also the length of it. And once that's done, the designer can just generate the drawings of whichever is required by clicking on generate drawings, and the same thing can be added to the project, or they can export it to text, XML, or you can see the formats here, that is Excel, text, and XML formats. So we can also just double click on it and see what are all the different types of references, marks, description, and we can see the wire harness list as well. So with this, I would like to conclude the SolidWorks electrical part. So if you have any questions or any clarifications on whatever was demonstrated, or if you want to see a detailed demonstration other than this, you can just put your questions in the chat window, or you can just contact the marketing team. The email IDs will be displayed at last, so you can just post your questions or any queries with respect to electrical over there. So thank you all for the time provided. I would like to hand it over to Madhusudan to continue with the next part.
Yeah, thanks, Sindhu. Just make me the presenter. Yes.
Yes, you are presenter now. Thank you.
Yes. Okay. Let's see. Thanks, Sindhu, for that presentation on the electromechanical integration. So we saw that from the past half hour, 45 minutes, how we can design inside SolidWorks your solar designs, and then how we are going to validate it. And now we saw the integration between the ECAD and MCAD, which plays a very critical role in your solar power designs. So now comes the most critical part of it. This is where the quality control, that is your designs and documentation, plays a major role, especially for the solar manufacturers. So they need to make sure their documentation are intact. So for that, SolidWorks will help you in that line of work as well. So with the help of the tools that we have, for example, we have for the quality control, we have a tool called SolidWorks Inspection. which will help you to easily take your SolidWorks drawings, or it could be your PDF drawings. We can pull out those SolidWorks and PDF drawings inside the SolidWorks inspection and readily create all those balloonings can be done right away. And the best part about SolidWorks inspection is even the informations, the metadata that you want to enter it in your Excel sheet with your technical documentations can be easily extracted from the model which you have added. So this almost reduces the task, and also you can also select the range and the time things that you want to capture on your technical documentations part. So this is one of the examples that I'm showcasing you upon, and also in the each of the balloons that you define, you can define what is the method that you want the technical documentations or the inspection methodologies or the instrument that you are going to use it. That can also be specified and made it more streamlined. And that doesn't end there. Once you even generate the Excel format sheets, so the moment you enter the values, it will tell you that whether the particular value is in the range or not, with the help of a simple color coding. If it is not in the range, it will show as a red, and if it is in the range, it is shown as green. So what is the benefits of using the SolidWorks inspection? So with SolidWorks inspection, it gives you the flexibility of either working with your SolidWorks files, or it could be the third-party files, or native formats or universal formats such as your PDF files or TIFF documents, or even your 3D models from other format tools. Yes, I said it right. It's even from the Creo files with all the 3D annotations in that, or it could be even your Autodesk Inventor files with all the 3D annotations. You can import it inside the standalone version. It gives you the flexibility of even handling and doing the revision management as well. So that means to say, if there is any changes with the new model, it can compare the documents and it can replace with the old ones, and your technical documentation will be ready. So this is one of the key things that I thought inspection would play a major role for the solar manufacturers, or your solar designs, panel drawings, or it could be your designs where you need to showcase it and give this to your vendors, or it could be your contractors who are going to manufacture that. These things can help you to streamline that. With SolidWorks inspection, you will be able to reduce as much as 90% of your work. Now let's talk about even more interesting topic, that is going to be your technical documentation. When I talk about technical documentation, most of the companies today are looking at something that is more of a content that is towards a digital content, where we can publish this to our clients. And that's the exact opportunity that you get when you're designing with the 3D. Not only you will be able to use your documents, you use your 3D models to visualize your things, but you can use it for the other variants, such as your marketing department, after sales training, technical documentations, manufacturing, you name it. 3D CAD models gives you multiple opportunities. Now let's see how the composer inside the technical documentation, or the SolidWorks composer, really helps you to manage your technical documentation in a more easier and a much more easier method. What we can do with the technical documentation with the composer, we can create views, render the effects, and bulk the output in an easier method. Let's see how we can do that. You can capture each of the views that we have done, and those things can be published and showcased in a way where a customer can easily understand. The best part about the composer is it doesn't stop you with their own native formats. It also gives you the universal formats, such as your PDF, which can extract the same amount of content that we are seeing right away, and these contents can be extracted in a 3D PDF formats as well. And you can also save it as a normal STL format or SVG format, where you can open it with just a web browser. So with this, you can also create all your standard operating procedures, or it could be your assembly units, assembly instructions, which is very important for solar, which is a turnkey based companies, which their installation happens at the remote location, where 3D would be a more preferred option for the vendors or the clients who are going to work on that. So this is where the composer will help you to do that. And along with that, the next part, so how do we visualize stuff? So in case if I really want to publish my if I want to visualize, or I want to showcase this designs to my client, how do I do that? with the help of e-drawings, you can easily share your data or 3D designs to your clients or to your team members who don't have a CAD license. And with this e-drawings, it's not just a viewer tool. It gives you more than that, where you can view and you can check the e-drawings document. And also now with the e-drawings, you can also see it has a HTML format file. So that means to say, even an HTML format, you can, without having to install the e-drawings, you can open up in just a web browser in your system and you can view the files. But the best the viewer tool, you can change that. So virtual reality is almost stepped up in almost every department, or I can say in almost all the domains in the world. Solar also, you can use the virtual reality, the power of virtual reality, where you can showcase how exactly your solar plant is going to pan out even before you manufacture them, or even before you commission the entire solar power plant. You can showcase this to your customer with the virtual VR glasses. They will almost be as realistic as possible can get to the reality or real content that you can get. So this is the advantage of using the e-drawings. Not only just offers you the best in class e-drawings files, but at the same time you can pan, zoom in, zoom out for your team members who don't have CAD files, who just want to view the files in the 3D. And it could be even your shop floor people who want to see how exactly the panning out really happens. So these things can be seen with your SolidWorks e-drawings, or the e-drawings that you will be getting from the SolidWorks. So what is the advantage of this? Of course, you're going to use the power of VR, where you can showcase or you can feel the experience of your plant layouts inside your company, where you want to showcase this to your higher ups, or it could be your clients who wants to see that how exactly does the layouts looks like, and the HTML format file. So there is no restrictions or system restrictions for this. Even you can share the content over the FTP formats or WhatsApp, you name it. It is absolutely more easy and more simple than ever before to share your designs to your customers or to your people who don't have any kind of tool to view the files. So with the help of e-drawings, you will be able to do that going forward. So that's the best thing about the e-drawings. Now let's talk about the final topic. How about bringing all your files to life even before you manufacture them? So that's exactly what Visualize does. So with the technical documentation, as I said, SolidWorks gives you a range of designs which will give you the designs. So with this, I come to the end of the session. We are open to the Q&A. Please post your questions. We are ready to take the questions now. So, and before that, let me just do a quick recap of what we did. So we have multiple clients as well, and the most important thing that we are gonna we saw in the last 1 hour. I'm sorry that we extended a little bit of couple of minutes from what we scheduled up, just because of the content that we want to showcase to all of you. So first, let's see quickly do a recap of what we did. We saw the optimal usage of the CAD tools and structural design with Srishel showcasing the entire thing.
And your presentation is not visible. It is stuck on your drawing.
Okay. Is it? Yeah.
No, it's fine, Madhu sir. You can continue.
Yeah.
It is
okay. Yeah. Okay. See, the structural, sorry about that. The structural design is going to be made easy with your CAD libraries, and integration with the electrical and electromechanical designs made easy with electrical, and with the collaborations. Your collaterals becomes more easy with the help of the instruction videos and stunning images that we are going to have. We have tools for that to support that as well, whether it could be Composer or Inspection, or it could be even your Visualize, which helps you to can help you to see that VR, and the quality control documents we have with the inspection documents. So these are the things that the solar power industry will get benefited with the help of the SolidWorks ecosystem, because with the kind of products that we have, we would be able to easily offer you, and the kind of challenges that you are going through can be easily overcome with the help of SolidWorks. So now I'm open to Q&A. If anyone has any questions, please do post it so that we can take some questions over here. Yes, the first question is by Samir, saying that can we use the same process for the rooftop installation as well? Yes, of course. Some of our customers, I hope it is related with the difference between the, I hope it is related with the CAD that what you are asking for. Yes, some of the companies with our clients who have done the rooftop designing as well inside SolidWorks. For the solar panels, some of the companies like ABB, or it could be Vestas Equipments, they do work on the rooftop installation as well. So yes, and yes, it's regarding with the simulation part. I think Srishel can answer this. Srishel, can you take this and explain more with Mr. Shamir about the structural part? Srishel?
Hello.
Yeah, Srishel. Yes.
I'm not able to see the questions. Can you read it for me?
Yes, Shamir is asking me that can we use the same process for the rooftop installation as well? What will be the difference in terms of the structural validation?
Yeah, we can use the same procedure wherein especially the wind loads and structural analysis follows the same procedure. There is no much difference in terms of the rooftop and on the solar farm. I hope, did I answer your question, Mr. Samir? If you have more questions, please let me know. Any other questions?
The next question is, what is your solution for shadow analysis on rooftop projects?
Shadow analysis is basically included in SolidWorks CAD module itself, wherein you can give all the altitudes, different altitudes, and based on the regions where you are doing the shadow length analysis can be done within the CAD environment itself. Am I right, Madhu?
Yes, exactly. Because that's the help of the visualize or the e-drawings that we offer, where you can even do the same replication can be done in your e-drawing files as well, where you can check how the shadow images do follow them.
And the other question is, can we go with this design tool for bifacial module structural designs?
What is that? Please come again.
Can we go with this design tool for bifacial module structural designs?
Bifacial in the sense, can you please elaborate, sir, on these particular questions? I'm not able to understand it. If I understand it right, yeah, if I understand right, they might be asking about the fluid structure interaction, where, as I shown in my presentation, fluid structure interaction, that is the wind load, importing the wind load from SolidWorks CFD module to SolidWorks finite element analysis is possible. If you would like to know more about this, please do let us know, sir.
And I think there's one more question by Mr. Girish asking, does it calculate the shadow losses based on the obstacles?
Madhu, can you please answer this question?
Shadow losses is something that something that if you're checking it in the CAD part, no, we wouldn't be able to do that. It doesn't give you any kind of a calculations part, but yes, in terms of the visualization, that how does the shadow pans out in your CAD model or in a real life scenario, that we can surely visualize that.
So with this, I think no further questions as of now. I think we will end the session. If you have any more questions, please revert back to our marketing mail IDs from which you have received a mailer. So thank you all for your time. Hope you're all safe. Take care. Thank you.
Yeah. Yes. Thanks for your time, everyone. And in case if you have any queries, and also I suppose there could be a lot of queries from your teams or from your end as well. Please write back to us so that we can get back to you on that, and we will help you out understand if there is any challenges that you are facing. And in case on any of the topics that we demonstrated in the above topic or in the present webinar that you want to know in detail about that, please do let us know to write back to us. Either it could be Srishel, or it could be Sindhu, or it could be myself. You can write back to us and we will help you out and reach out so that we can understand your present requirements, and we can help you out that how we can overcome your present challenges that you are facing. So with that, we will try to end the session now because we have extended the time almost by 10 minutes. I'm sorry about that. We were sorry about that. We just wanted to showcase almost all the content to our to you guys, and to tell you that what is the entire ecosystem of SolidWorks really has. And we will also post you the recording sessions of this particular webinar, which you can follow it up further. And thanks everyone. Thanks once again, and you've been a wonderful audience.
Okay, thank you so much. Can we end this session now?
Yes.